I'm going to go over the homework with you. This is 9.1 Roots and Radical Expressions. I do want to review with you, for example, we have the power, which is n, and you see that arrow goes both ways. It means the same thing. We're using the a variable, we're using the n variable, we're using the b variable. And so you have the radical sign, and then what's inside the radical sign is called the radicand. And then the index is also called the root. Okay, so the index is the root, the radicand is what's under the radical sign, and of course we have a. And you see the arrow, that means it goes back and forth. This is a review right before you do the assignment. It's good to just listen to this and you might have a better understanding of it. This is telling, and this is the radical, the radicand, and the index. So this is the root. Because 7 to the third power is 343, we know that that's an odd number, so there's exactly one root. In this case, it's 7. Notice that negative 7 raised to the third power gives you negative 343. So negative 7 is not a cube root of 343. It's actually the cube root of negative 343. Remember that if you have the fourth root of a number, you're going to have two roots. So here's a good example. We have the fourth root of 1 over 625. And because 1 to the fifth, 1 over 5 to the fourth power is equal to 1 over 625. And also negative 1 over 5 raised to the fourth power is 1 over 625. So both 1/5 and negative 1/5 are real number fourth roots of 1 over 625. So remember, if it's the index is 4, in other words, it's even, then this will have two roots, positive and negative. This says to the third root, the index is to the third root, so it's odd. So you know it's going to be one root for this, and the only one that's going to satisfy that is negative 0.43. Negative 0.4 raised to the third power, that gives you negative 0.064. So therefore, the third root of negative 0.064 is negative 0.4. Now we're getting the square root of negative 25. And it says here, because 5 squared equals negative 5 squared, which equals 25, neither 5 nor negative 5 are square roots of negative 25. Remember, they are imaginary, but we're not talking about imaginary. These are non-real number square roots. These will not be real number square roots. So remember, if n, the index, is odd, then there's one root. If the index, or n, is even, then and if b is positive, then there are two roots. If it's negative, there are no roots. Okay. So if we do the square root of 169, we know that 13 to the second power gives you 169. So therefore, the square root of 169 is equal to 13. Because, like I said, 13 squared gives you 169. If you look at my calculator, I was doing some computations before I did number 2. We have 8 to the third power, which is 512. Before that one, it was 7 to the third power, which is 343. And then 9 to the third power is 729. So that tells you what's going to be the cube root of 729. The cube root of 729 is 9, since 9 to the third power gives you 729. So it's perfectly fine to use your calculator. Here we have the index is 4, or the root is 4. You notice in my calculator I did 0.2 raised to the fourth power. So I did 0.2 raised to the fourth power, so that gave you 0.0016. So if I get the fourth root of 0.0016, it's actually 0.2. You notice that 1/2 raised to the third power is 0.125, which is 1 over 8. Now we want it to be negative, So therefore, I'm going to try -1/2 and see what happens when I raise it to the third power. So I encourage you to do this in your calculator or Desmos. -1/2, raise it to the third power, and you notice you get the same decimal value. And I'm going to go ahead and change it to a fraction, so you have -1/8. So the cube root of -1/8 is -1/2. So number 5, we have a square root, so it's an even, and we know that the b value is positive, so we know that there's going to be two possibilities. So you can either have 2/11 raised to the second power, or you can have -2/11 to the second power. So there's actually two roots. It's either 2/11 or -2/11, because that's going to give you 4/121. But the principal root is going to be 2/11. We have the cube root of 125/216, and we know that the index is 3, so we have exactly one root. And if you look at my TI-84 calculator, you notice that 5 to the third power is 125, and 6 to the third power is 216. So our cube root will be 5/6. Why? Because 5/6 raised to the third power is going to give you 125/216. I'm going to do these examples that are here on your reteaching. We want the cube root of 1,000. Now we know that 10 to the third power is 1,000. We know that y to the third raised to the third power is 9. So if you get the cube root of 10 to the third is 10. The cube root of x cubed is x. And the cube root of y to the third, which is raised to the power 3, is y cubed. Okay? We have b, and we have the fourth root of 256, g to the 8th, divided by h to the 4th, k to the 16th, and you know the index is 4. So you want to make these all into powers of 4. So 256 is 4 to the 4th, which if you get the fourth root of 4 to the 4th is 4. G squared raised to the 4th, it's going to be g squared. H to the 4th is just going to be h. K to the 4th raised to the 4th is going to be k to the 4th, and there it is, okay? The absolute values are needed to ensure that the root is positive when h is negative, okay? So for number 7, I know that 36 can be rewritten, and I know that the index is 2. It doesn't indicate, but the index is 2. So you have the square root of 6 to the second power, x to the second power, and when you get the square root of 6 squared, it's going to be 6. When you get the square root of x squared, it's going to be x. So if you want to think of it, the two like cancels. The index cancels with the power, if you want to think about it like that. Number 8, we have 216, which we did. If you look at our calculator, we've already done it. So I'm going to rewrite this a different color. We have a cube root, and we want to write everything in terms of powers of 3. So we have 6 raised to the third power, y to the third power, so that's fine. So remember the index, which is the root. The cube root of 6 to the third is going to be 6. And then the cube root of y to the third is going to be y. So when you get the cube root of 216, y to the third, it's going to be 6y. Now for number 9, we're going to go ahead and rewrite it, because remember, by default, if there isn't an index, it's 2. It's actually the square root. So let me rewrite this with the 2 in mind, the second power. So I'm going to have 1 is equivalent to 1 squared. 100 is equivalent to 10 squared. And then you have x squared, and don't forget the radical. So the square root of 1 squared is 1. The square root of 10 squared is 10. The square root of x squared is x. So it's 1 over 10x. Let's go ahead and do number 8. And I'm going to move it just slightly. Number 10. I'm doing number 10. And we notice that we have x raised to the 20th. So remember, we're going to have a power raised to a power. And we know that the index is 2. In other words, it's x squared. So it's going to be x to the 10th power raised to the 2nd power. And this will be the square root. And this is y to the 4th power raised to the 2nd power. And you're probably wondering, how did I come up with them so quickly? Well, I know that 20 has the factors of 10 and 2. And I know that if I want to get the square root of x to the 10th raised to the 2nd power, it's going to be x to the 10th. Okay. And if I want to get the square root of y to the 8th, I know that it's going to be 4 raised to the 2nd power. And like the 2 cancels with that, so you're going to have y to the 4th power. Number 11, we have the cube root. So we really don't have to rewrite what's in the numerator. So I have the cube root, and that's already raised to the 3rd power, so that's good. It's a denominator that I got to worry about. So it's going to be x minus 4 raised to the 2nd power. And then once again, it's going to be raised to the 3rd power. And you notice I use bracket just so you can notice the difference. 2 times 3 is 6. So what happens when you get the cube root of x plus 3 raised to the 3rd power? It's going to be x plus 3. And what happens when you get the cube root of x minus 4 raised to the 2nd power, that's raised to the 3rd power? It's going to be x minus 4 raised to the 2nd power. So now I want each of them in terms of to the 5th power. So let me do some rewriting. So we have x raised to the 2nd raised to the 5th. We have y raised to the 3rd, raised to the 5th, and then z, I don't have to worry about z because z is already raised to the 5th, and I'm going to get the square root. And by default, not the square root, I'm sorry, the 5th root. So you're going to get the 5th root of x squared raised to the 5th power, which is just x squared. You're going to get the 5th root of y to the 3rd raised to the 5th power. It's y to the 3rd. And then you're going to get the 5th root of z to the 5th, which gives you z.